Here we are asked to solve the equations for x. So first one here that I'm going to deal with, x to the power 4 plus 5x to the power 3 plus 9x squared. I'm just going to add that 45x over to the other side, and then I'm going to factor and solve. So first thing, I can factor out an x to make this just a cubic function left over, which is nice. And now to solve the rest of this, or to factor this first, I'm going to use rational root theorem to try and find the possible rational roots. So possible rational roots are going to be plus or minus 1, 3, 5, 9, I think. Oh no, I messed something up. Hold on. Maybe it's 9. Oh, we'll go get 9. And then 15, and then 45. Maybe I'm missing one, but hopefully that covers them all. From there, I'm going to use synthetic division to actually plug these values in. So because they're all positive, I know I'm going to have to plug in the negative values to minimize on my time of plugging things in. But I'm just putting the coefficients of this down, so 1, 5, 9, and 45. Bring down the first one, multiply and add. Multiply and add. Okay, this didn't help because it didn't get to 0. So that one's not going to help me. Let's try -3 next. So same coefficients. Bring down the 1, -3, add, multiply, add. Still didn't help me, so that one does not work either. Let's try -5 next. I have a good feeling about this one. 1, 5, 9, and 45. I bring down the 1. I multiply, I add, I multiply, I add, I multiply, and I add. Woo! Got it. So, cool thing about this, once I find one that gives me a remainder of 0, that really means that if I plugged -5 into here, it would give me 0. So, now my fully factored form, remember that original x up here. Now the -5 here means that x plus 5 is part of my equation, and then this here tells me what's left. So I have a remainder of 0, a constant of 9, a 0, x factor, and then positive x squared. So now this is my fully factored form of the original equation that I was given. So now to solve, I'm just going to solve each of these pieces. So x equals 0, x plus 5 equals 0, and x plus 9 equals 0, x squared plus 9. So first solution, -5 makes sense because I saw it right here. And then x squared equals -9. I got to take the square root of both sides, which gives me positive or -3i because I have the square root of a negative number. And that should give me 4 solutions. 1, 2, positive I, and -3i. So 4 solutions make sense for this one because I originally started with x to the power of 4. So for the next one here, same kind of process, I think. Let's try it out. First thing I'm going to do is move everything over to one side. When I do this, I'll look through here. My only possible rational roots are going to be positive or -1. So 1, we will try this by plugging it in here. 1, -1, -1, and +1. Bring down, multiply, add, multiply, add, multiply. Hey, there you go. Okay, so 1 worked, meaning, actually, let's change colors here, meaning that 1 is going to be one of my solutions. X minus 1 is part of my equation. And then x squared minus 1 here is also part of my factored form. Now, one of two things, I could factor this even more if I wanted to. I could say x minus 1, and this is a difference of squares, so x plus 1 and x minus 1. And so really what we should see is that we're going to have a double root here at x minus 1. So I have 2 roots, one at -1 and a double root at x equals 1. So really only 2 solutions on this one, but we do have a double root, which gives us our 3, in air quotes, solutions.